So common logs have a base 10. So common that we don't even write 10 in the base anymore. If you see log 5, that means it's base 10. Okay. On your calculator, on the left side, there's a log button. That's log base 10. Right. So log 1,000, 3. That one you don't even need a calculator for that one. Because it's log base 10, and this is 10 to the third power. So again, logs. What exponent do you need on 10 to get 1,000? That's the question. Okay, 10 to what power gives 1,000? So just a definition, log base 10. There are lots of different problems in this section. If you look in the book, there are 8 examples. I'm going to show you many of them. Okay. Let's say if you don't have a calculator, let's say log 5 is that value, which it is. That's a 0 at the end. Evaluate that right there. Any ideas? No calculator.
You multiply.
You know what log 5 is?
So can we just multiply them?
5 times 10,000 is 50,000, right? Okay, what property of logs can I use to split those apart? Yes. Right, that's that property of multiplication. I told you yesterday, if you have 2 logs the same base that are added, you can multiply the numbers together, or vice versa. Split them apart.
What does the top part have to do with anything?
This? What's log 5? So we know log 5 is 0.6990. And log 10,000 is 4. Because it's 10 to the 4th, right? So it's 4. Yeah, so now add. Good one. Thanks, Jansen. Okay. I've kind of talked to you about pH a little bit, right? Yeah, chemistry. There's an example in your book that deals with chemistry pH. We can use logs because pH is on a logarithmic scale. So let's do that example. Okay. Let's say we want to find the pH of a solution. or of water, really. Okay. It says drinking water is routinely tested for its pH. The level of a solution is considered is a measure of acidity in relation to the concentration of hydrogen ions in moles per liter. Got it? Okay. Let's say we have some water. It has 7.94 times 10 to the negative 9 moles of hydrogen per liter. What is the pH? It's H plus, so hydrogen. So if you're measuring the concentration of hydrogen, is it very easy to report this number every time? No, it's not. So what they do, and they do the same thing with earthquakes, is we adjust it with that equation. So the actual number pH that you're reported, 1 through 14, comes from this equation. All you do is you plug your number in, calculate a log of it. So in our example, use your calculator. Now make sure that the bottom is in parentheses. If you do not put it in parentheses, your calculator will divide 1 by 7.94, get an answer, multiply by. Okay, so make sure that bottom is in parentheses. You should get 8.1. So go ahead and try that. Okay. Sorry. How'd you type it in, Dylan? Oh, yeah. That's what you need to do. Just write it here. Okay. pH is a lot more important than we think because things kind of just work. If you have how many of you have gardens at home? Gardens? Okay. So I'm reading about carrots last night, and one of the things it says is, no, this is not random. March is coming. It's time to indoor plant so you can get a garden rolling in June where I am. But carrots require a specific pH range. If you can optimize the pH of your soil for each item that you're growing, you'll get more production out of it because it's got optimal conditions, right? It's kind of like instead of drinking soda and eating a candy bar for lunch, Okay. Yeah, pretty much you're drinking water and eating a salad with an oil dressing on it. Okay. You're healthier. Gabby.
I read that if you grow hibiscus in different humidities, you can get specifically enough flower
Probably.
somehow.
Yeah, I have no idea, but
I don't know.
that's, and the other reason, yeah. So if you're aware of this concept, you can actually use it. You won't have to do the math, but you can send your soil off, get it tested, you know, and you can add lime or fertilizer, or you can amend your soil so that the pH is optimal for that specific crop. So
How come we use like chicken and cow food for fertilizer?
animals, those, say you have a cow that eats grass, it poops it out. Okay, what's in it? Poop, right?
Yeah.
The breakdown of grass. Well, when you compost that, it breaks down into nitrogen and potassium and phosphorus, the three main ingredients for growing crops. Yeah. So when you compost it in the dirt, it adds, it's basically like taking a bag of lawn fertilizer and throwing it on there, but it's natural fertilizer. A little bit more nitrogen heavy than some plants like. So if you can add some phosphorus, like, oh, what plants is it? Can't remember. Some plants love nitrogen. Grass loves nitrogen, just because you want it to grow. But nitrogen tends to leaf out foliage better. Phosphorus and potassium tend to make roots and tubers grow better. Potatoes, carrots, stuff like that. Okay, I digress. Let's continue. If you ever talk to me about anything food, you'll have my attention.
Last night I was
Food.
up and had bacon and
Anything food.
ham and ham.
Hunting, gardening, buying, selling, making, canning, freezing.
I know it was
It's good stuff.
Yeah.
So evaluating basically these, I know you can punch these in your calculator. These will be no calculators exercises. Okay. To a point. Yeah, thank you for that. The question is, can you break this down to a point where we can use a calculator? Okay. Those are multiplied, right? 3 times 5 squared. So what?
25 times 3 times 25.
You can break it apart. Yeah, I know you automatically want to start punching keys. Yes, I know. What can I do with the 2? Now, in the old days, you know, before these fancy calculators were out, they actually had a table of values that went from log 0 to 10, and they would have to reference a table. So we couldn't do 25 unless we broke it down. Okay, so that's kind of the old days still sticking with us, because I know you can punch it in a calculator. Go ahead and punch that in a calculator. We can actually get an answer. I hear 5 different answers. Survey says?
1.6.
Yes!
Yeah.
Yeah!
I don't know if that's right. That's what I heard the most. I don't have the answer.
That's what I got. I got it.
I'm pretty sure it is right though.
How did you get that?
What's log 3? Do them separately if you have to.
Oh, I know what I did.
What's log 5?
Okay, I entered. No.
So we've identified our issues. The other form? You could, but it would put the y in an exponent. It wouldn't do you any good there. Okay, here's the biggie for the day. Change a base formula. This allows us to take any base and put it in log base 10 form. So let's just say I have some arbitrary base. It can now go away with that little formula there. We've changed it into base 10. Up until recently, we couldn't even do obscure bases on the calculator. You can now. Recently, according to me or according to you?
Like
In the last few years. Technology recently, 10 minutes ago. We could only do log base 10 on calculators, but if you go into the math menu on the TIs, a lot of them have at the bottom, there's a log base function.
Yeah.
The black ones may not have it.
Yeah. This one's older than that.
Yeah.
Where am I going
It's a
now?
new, it's the newest operating system.
Math what?
Math down, so, and it should say log base.
Nope.
Yeah, the black ones don't have it. The yellow ones should. So
Got it.
yeah, what's log base 8? 16. Right, because you can do it on your calculator, but you'll need this formula. You can change it to base 10. What is it? So be able to use that. That's the point there. We'll use it here and there. Okay, here's a good one. Let's assume water has a pH of 6.7. We're going to move into solving equations. What is the concentration of hydrogen ions? Remembering this. Where does 6.7 go? There. Okay. Ideas. Yeah, we need to isolate the H. Can I multiply it out? That log is like its own little cage. It can't come out of there yet. Can we rewrite it as an exponential?
Yeah.
Yeah, rewrite it as an exponential. What's the base? 10? Exponent? The log is gone.
The log is gone.
Now we can multiply the h plus out, right? And divide by 6.7. So what we end up with is that number. What do we got? What? I must be getting hard of hearing. Pretty sure that's a decimal that's really small. Might want to check your calculations.
I got one.
I got the same thing as that.
That was the bottom. Yeah, that was the bottom.
I got, 1.9.
I was talking about
That is what you should get. It's a really small decimal. How you doing? Oh, that does explain things a little bit. I can't explain anything to you. Are you okay with that? Again, every day we're kind of addressing and solving these. Here's another example. And another way to solve these. So can you should be able to rewrite this as a x log, right? Okay, so what would it be? Change a base, and then you divide by 3, right? You get some value. You should get 0.8175. There's a second way we can tack this too. Take the log of both sides, base 10. What can I do with the 3x? It's an exponent. And then divide by. And you should get, again, you should get 0.8175. Okay, so all right. Any questions? Lots of sitting and thinking today. Okay. No, you can't. Well, you can. If you want to deal with your school. Not so much. Wayne's World. Yeah, it's a good show. It's a good show. It's definitely a 1990s film.
Yeah.
I know.
Doesn't get better.
It does, but it's pretty good anyway. 11:05. Let's see. So Tuesday is practice park. Wednesday is.
No one's here.
Are you guys knowing me, or is that chemistry bio day? Wednesday.
Yeah.
Okay, and that's in the morning, right? In the morning. So
I get to Oh, yeah.
all right. That pains me to write that down, but such is life, right?